Okay, good morning, everybody. Let's continue the slides from, I would say, Thursday last week. So yeah, we'll start with some admin stuff, right? So yeah, people are asking about the review. So the review will take place most likely either today, later in the day, like maybe like 3 p.m. That's a review for exam number 2. Or tomorrow morning around 9 a.m. So, but either way, I'll record the review. It will be there. So it will be in Zoom as usual. So if you can make it, then you can join. So I think about maybe like 10, 20 people join typically. So, but everybody else watches the recordings. So it looks like it is helping at least to some extent to somebody. So, which is great. Bless you. And yeah, so this will be done. So it's kind of like voluntary on my end to deliver reviews. So that's why I kind of like can control this delivery time of them. And then it's going to be either today, later, about 3 to 4 p.m. or tomorrow, like 9 a.m. to 10 a.m. So, but either way, it's going to be published. So as soon as possible, and then you'll be able to like watch it, right? So then also in terms of review, so not the review, but rather feedback. So like for exams, you can pick them up. So I brought some here today. They are not alphabetized. So you probably need to kind of like sift through a bunch of them until you find your name. So you can pick it up today, right after the presentation, or just go to the office and then pick it up still, right? So I'll be there like for the office hours. And then you can also like get your individual like feedback, right? What happened? So maybe argue a little bit with me so about the points, right? That's also possible, and then gain something back. So if I overlooked something, so that's entirely possible as well, right? So yeah, this is all kind of like on the table, or you can just pick it up, review, and then come back later, and then like talk about some like details or something that you disagree with, and then argue with me. So yeah, that's kind of like the things that are on the table for now in terms of like auxiliary things. So yeah, statistically, the average was pretty high this time around. It's like about 77%. So that's like where you are, right? So the range was about, I would say the range was, let's say 74 points, right? So from the lowest to the highest score. Some people scored so much that it was not enough, right, to give them the grade more than enough. So yeah, again, so it's all kind of within the realm of possibility, depending on your like review, study skills, whatever. So hopefully, yeah, you don't cheat. So yeah, that's kind of like not helpful. Typically, I literally know one person who was cheating, and then he's like very successful now. So yeah, that's just kind of like FYI. I guess everybody is different. So yeah, but anyway, so now let's take a look at some like things that we are going to continue with. So according to Finnegan, there was a question already about where do we start naming benzenes, right? So yeah, that's just kind of some review, right? So one of the like biggest things where people were like scoring low was the functional groups, right? So yeah, they were pretty straightforward, so nothing tricky. So, but they need to be remembered, right? And then so some people are trying to describe the functional group, what it looks like. So yeah, I was trying to give the partial credit for that. So, but again, so some names are kind of set in stone, and then in the literature, they will just be encountered as such, right? Or benzoic acid, and it's not going to be described as some sort of like cycle hexagon with the carbonyl and the hydroxy group. So that's good that you kind of like break those down, right? So that's why I was given the partial credit. So, but again, so conventional terms are good to remember. And then some people kind of like blasted through them like very nicely. So like listed all the functional groups without problems, right? Also, it includes spelling, right? So spelling will matter. So such as kind of like a phenyl versus like a phenol, right? Some people kind of like misspelled letters a little bit. So they were still getting almost the full credit, but still the spelling will matter because as you maybe recall from your previous experience, right, from exam 1, alkane versus alkene, right? So those are very close spelling wise, but they kind of like are hugely different in terms of the structures, right? So same here. So yeah, those like are the names to remember. So because those compounds you will encounter a lot. So if you go, for example, to the grocery shop, then you will find benzoic acid a lot, right, as an additive, especially in Jarritos, for example. Unfortunately, it contains benzoic acid, except unless it is tamarind flavor, so it doesn't have benzoic acid, right? So, but fruit punch, for example, so all those are conventional things, will have the benzoic acid, right? So that could be like encountered in a common kind of like, it's a soda product, for example. So same with phenol, right? So phenol, if you look at this, it is an alcohol, then aniline. So again, so here we can find some familiar already. It is just like building blocks which are put together into the new compound, right? So we can see the base. So some people like did well actually. So on the like bonus point question, so they were able to find or to add for example, the H plus to an amine. So here you have the same behavior, right? So you also have this kind of like NH2 group, so which signifies an amine, and amines can behave as bases because of this kind of like lone pair, right? So same with that, guys. So here you have technically the bond, right? So between O and H, I'll just show it as a purple dash. So, but it is a bond, OH bond, and then this can dissociate. So some people were also showing dissociation of the like carboxylic acid bonds. And then here we have just another example, right? So it's again, so like maybe we'll put it again for the like extra points for the presentations, right? If you want to give it another try, you might as well regain the points to some extent for the bonus point question, right? So it's always a good idea to attempt it. So some people are attempting that. I was giving it like at least like 1 point for some kind of like reasonable attempt. So, but if you show nothing, then nothing will happen, right? So no bonus points will be given. So just kind of keep it in mind, right? So yeah, but again, so everything is discussable. So yeah, then here we have our like alcohol, by the way, right? Functional groups, so COH piece, and then you have your aromatic stuff as well. So this one is kind of like least reactive, toluene, because it just has the like alkane, and also it has the like aromatic ring here. So yeah, but those things will be like more reactive because you have like highly reactive functional groups in these compounds. So this is just like for your reference for now. The kind of like largest extent of your knowledge can be how to dissociate, how to ionize the like bases and the acids, right? So that's where we will be. So then here, basically what you can see is that we have this OH group, which will dissociate, right? So, and then we have another OH group, which will dissociate. And then you can show they like ions, right? So that will be formed. So, but anyway, so yeah, these are kind of like the names that also are used officially by the like nomenclature, right? So that's something like that we can use in order to like name those compounds. So like which can be derived from these compounds, right? So for example, like what do we mean by that, by derivation? You can start with toluene, right? And then theoretically here, so if you look at this, you can show the like hydrogen, right? So because we need to already understand at this point that if we see the band here or this like angle, right? So it will mean that there is a carbon. So with already 1, 2, 3 bonds engaged. And then consequently, one more bond is like available for what? For binding with a hydrogen, right? So basically here, so in all those like 1, 2, 3, 4, 5, 5 bands, you will have the like CH piece, right? So like maybe, so I'm just like saying this in words, right? But you can like write it out like for your purposes. Maybe like turn it into the expanded structure just to make sure that you can see and count all the carbons, hydrogens, and so on in the molecule of toluene, right? So that's what we will encounter here. So like same things will happen in other molecules that you can see on the slide. So, and now let's see. So like those hydrogens which I highlighted, right? So let's put them into yellow. So those can be kind of removed. So as some people are saying, they can be swapped to something else, right? Such as maybe chlorine or bromine. That's how you will have the substituted like derivatives of those common compounds, right? So now let's move on further. So here we have a benzene, right? Technically, so we started, so we can think about, okay, well, we started with the benzene, C6H5, right? So, but now what you have the substitution going on, right? So if you count the hydrogens which are left over, it's going to be only 4 hydrogens left over. And then instead of those bromines, there used to be like hydrogens, right? So, but now they were like removed, and now you have the bromines. So, by the way, yeah, that's kind of like the way you can explain those reactions for now. Just see what you start with, right? Then you are going to break some bonds. In this case, you broke CH bonds and you removed H's. That's what people literally responded in their exam 1 penultimate question, or the last just regular question about the formation of the cycle, right? So, and then you will basically have the 3 electrons on the carbons, right? So that can be available to bind with the electrons on bromine, right? Let's say we can imagine that there used to be like green electrons bound to just hydrogen atoms, right? So now the hydrogen atoms were removed, and these bromines with the red electrons were introduced, and then they made the bond, right? So like green and red, green, red. So these are the bonds which are between carbon and bromine in these cases. So then what else? So there is something special about the nomenclature of substituted benzenes. So yeah, basically, if we have now like a little bit more complicated case, it is a di-substituted, right? So we have 2 substituents in the ring. They can be located relative to one another in like 3 different fashions, right? So maybe it's going to be like 1 and 2, right? So like if you have like 2 bromines next to one another, so you'll just need to count them, give the like minimal possible numbers to the carbons, right? Because theoretically, if you think about it, you can start with here, right? Your count. That's going to be 1, 2, 3, 4, 5, 6. 5, 6 is higher than like 1, 2, right? So that's not going to work out. You want to minimize the numbers just like in alkanes, right? So here the best case will be like 1, 2. So that's what we'll get. And then in other case, so we can call it, for example, like 1, 2 dibromobenzene. So that's one option, 1, 2 dibromo. So dibromo, the dibromobenzene, right? So that's one option for this like compound A. So that's what we can call it. So, or in other words, it could be also called orthodibrombenzene. So what does O stand for? O stands for like 1, 2. Basically, your 2 bromines, right? 2 bromo substituents are in positions 1 and 2, right? Or if they are like next to one another, so on adjacent carbons, basically, it's going to be the ortho positioning of those substituents. So then we can have the M for meta, right? So that's this one. So you have meta dibromobenzene. So maybe in other words, you can call it like 1, 3 dibromobenzene, right? So then everything else kind of like repeats, right? So I will not rewrite it. 1, 3 dibromobenzene. So basically, like M, this kind of cursive M stands for the fact that substituents are in position 1, 3. So they're kind of like they skip an atom, right, of the carbon, and then they attach the second substituent to the like, 3rd carbon like, in a row, right? So finally, you can have the 3rd arrangement possible, which is going to be this, right? Like 1, 4. You have 1 carbon, and you skip a couple carbons, and then finally you attach your substituent to the 4th carbon, right? So like 1, 4, that's the same as para. So that's what this cursive P stands for. So para, we can call it also para substitution, because the substituents are in 1, 4 or para relationship with one another, right? So then if you think about that further a little bit, so yeah, this is going to be called like 1, 4. So you can call it like 1, 4 dibromobenzene, right? So this dot 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 stands for like bromobenzene, basically continue the writing. So para stands for 1, 4. So, and if you think about it further, right? So like what happens if you, let's say, have the bromine here, right? So it's going to be the same as a meta, right? So because it's going to be bromine here and there, they will like skip 1 carbon, and then you will have meta. or if you have the bromine here and there, so it's going to be still the same compound, right? It's going to be ortho dibromobenzene. So yeah, you can only kind of have that many variations in terms of like how to attach two substituents to benzene. So that's our next iteration, right? After we just looked at monosubstituted benzenes, such as like toluene, right? So here you can only you removed one H and switch it to the methyl or hydroxy group or amino group or carboxylic acid, right? So these are all your common substituents. I mean, common functional groups, rather. So that's going to be a good idea to remember their names, which many people did. Good job. So, but if you find yourself after exam one in the category where you kind of did not remember, then probably it's going to be a good idea to review the functional groups, right? So they would be like easy points, relatively speaking. So now, finally, we have maybe the most complicated cases, right? So when we have like more than two substituents in the ring. So let's take a look at how to name those compounds, right? So turns out that a lot of the times, so they will be based on the kind of like conventional names, right, of those like popular benzene derivatives that we saw, right? So like those popular ones, it was like four compounds, four molecules on the slide, right? Like 2 slides ago. So such as toluene or phenol. So then you can see them here, right? So like if you look at this part of the molecule, I'm trying to just kind of like show it maybe in yellow, like this one, right? So the yellow area is nothing more than toluene, right? So toluene, but of course, in this case, it is substituted, right? It is substituted toluene because you removed a couple H's from toluene, and then you switched one H to the nitro group, NO2, and the other H was switched to a chlorine group, right? Or chloro group Cl. So this is going to be like a double substituted toluene technically. So then what happens, right? So like how do we like start counting? So according to the question, right? So apparently, so carbon number one will be where toluene has its functional group, right? Such as methyl, right? So as we remember, so methyl is this one, CH3, as we know according to like our names, right, and structures that correspond to those names. So apparently it was like accepted by convention that this carbon to which methyl in toluene is attached will be numbered as one, right? So that's where you are going to start your numbering. So then you are going to, next step, minimize the numbers for the substituents, right? So that you are going to have. So all right, so now let's take a look, try again. Okay, reconnection. All right, so you're going to minimize the substituents, right? So here you can theoretically go maybe counterclockwise, right? So it doesn't matter like which way you go, counterclockwise or clockwise. So if you go counterclockwise, then you will have 1, 2, 3, 4, 5, 6, right? So 5, 6. Now, those are relatively high numbers, as opposed to if you go clockwise, you'll be like that. 1, then 2, 3, 4. So 2, 4 are lower. So this is a lower set of numbers. So then that's what we have. So like apparently, if carbon to which the functional group of the original toluene is attached, the methyl, right? If the carbon with the methyl will be number 1, then carbon with the nitro will be 2, carbon with the chloro group will be 4. So that's what we are going to do, right? So like basically our like base name or the root, so to speak, will be at the end. So that's your like toluene right here, right? So it's going to be the root of this name. So then you are going to, just like in alkanes, you will show the number of the carbon where the substituent is located. On carbon 4, there is a chloro group. On carbon 2, there is a nitrogen group, right? So that's what we are going to have in this particular example. So now we are going to arrange the groups alphabetically, right? So lots of people did a good job with that. So C first, then N, right? So that is like alphabetized. So then we are in a good shape here. So then what else? So like we can have also some sort of like other derivatives of our common organic compounds, such as maybe, let's take a look at now this one, right? It is a phenol. So, but of course, it's not just phenol. It has like a bunch of bromines attached to that. We can call it as substituted phenol, right? So then the root of this name will be phenol. So that's what we identify first, and then we can see the substituents, right? So no matter how we number them, so here again, same thing, right? So where the carbon, which bears the functional group of phenol, will be number 1, right? So that's what's the functional group of phenol? It is the OH, right? So this one. So OH is the functional group of phenol, which makes phenol, right? So now the carbon which has it will be number 1. So now we're going to like clockwise or counterclockwise, doesn't matter. We're going to get the same set of numbers for the bromines, right? So it's going to be 2, 4, 6. So if you go counterclockwise, it's going to be still 2, 4, 6, right? So that doesn't matter. So that's your best possible sequencing of the numbers. So, and then you're going to say, well, on carbons, 2, 4, 6 bromines are located, right? So here apparently you have like bromo, right? They're all the same. So then you are going to have the Greek suffix, which is tri for 3, right? Kind of like a similar. So, and then basically you can say that amongst carbons 2, 4, 6, three total bromines will be distributed, right? So 3 bromine groups will be attached to those carbons. So, and then here you mentioned like 2, 4, 6, 3 bromines. So it means that each of those carbons will have to get 1 bromine, right? So you cannot somehow randomly attach a couple bromines to like, for example, like here, right? It's going to be impossible. You'll be making pentavalent carbon. So then what else? So another one that we have is going to be kind of like more interesting a little bit, or maybe not, who knows. So, but this one is just benzene, right? So which is substituted. So if you continue describing this compound. So what do we have here? So it's a benzene. So we don't have any like common name to that. So like, but still, well, actually, we do have a common name. So if we think about that, so it is nitrobenzene, but it's not as kind of like popular as the 4 that we saw before, right? So these are the names that we'll see kind of like a lot, right? And then based on those, you can kind of like name your compounds, right? So you don't have to like say that this is some sort of like a benzene acid, right? So or amino benzene. So you can just call them this way, and then use those like names as the root for the bigger names, right, of the other derivatives of these compounds. So now let's take a look at compound C, right? So here actually it is based on the name of benzene. So I was wrong. So nitrobenzene is not the common name. So yeah, scratch that. Aniline, NH2, right? It's going to be the common name. So here you have the benzene, and then no any like common compounds can be kind of like seen. So what do we have here? So benzene will be the root of the name, right? So then we'll have our substituents, right? Which will be here 3 of them, right? So we're going to have the NO2, which is a nitro group, right? So it's not some kind of like nitrogen oxide because this NO2 is connected to the carbon, right? It's not the same as nitrogen oxide. So then we are going to have our bromo group, and finally we'll have the ethyl, right? So we have 3 substituents total. So then they're all attached to benzene, right? So which apparently lost 3 hydrogens total to like make it happen, to make this substitution pattern happen. So benzene will be the root of the name. So now we're going to maybe like start in no particular order, but maybe like arrange the substituents alphabetically, right? So bromo, ethyl, nitro. So BEN. So they go alphabetically. So now what is next? So we are going to give those like substituents the smallest set of numbers, right? So here we go. So like we, for example, have we have ethyl, bromo, and nitro, right? So if we start numbering from here, from this particular carbon, so that's going to be carbon number 1, then we'll have substituent number 2 and substituent number 4. So, and then also it's gonna kind of like follow the alphabetical order, right? So we have Ben 214. So another way to kind of like start numbering that potentially will be maybe like from the bromine, right? So let's take a look at that. If it's going to be like theoretically 1, 2, 3, 4, 5, 6. So 6 is a high number, right? So that's going to be like not so good for us. So if we start numbering from the nitro group, for example, so maybe like this way, potentially to minimize the numbers, it's going to be 1, 2, 3, 4, right? So we are going to have 1, 2, 3, 4. 1, 3, 4 as opposed to 1, 2, 4, right? So 1, 3, 4 sequence is a higher sequence. So yeah, basically, so that's what we'll like need to sift through and then try to minimize the numbers. And then that 214 seems to be kind of the best possible combination of numbers, right? So then alphabetical arrangement, and then yeah, we're in a good shape. So yeah, basically here it's going to be like read as on carbon number 2, we'll have the bromo. Carbon number 1, ethyl. Carbon 4, nitro group. And that's it, right? So, and then they're all hosted on benzene. So now let's see. So here we have some examples, right? So probably, so like that's what we are gonna have on our exam, right? So like a lot of those names will be based on the names of the common compounds, right? So like which we can use as the root to kind of like ease our life a little bit, right? So in this case, we can highlight them. So like maybe in this situation, we'll have toluene, right? Toluene. You can call it a toluene derivative, right? So because you took toluene, you removed one of the H's and you switched that H to the iodine, right? So like now you made that compound, right? So here, if you want to name it, so you can do that. So as we agreed, so the carbon to which the functional group of toluene is attached will be carbon number 1, right? So now we have a choice to go like either way. So if we go, for example, here, it's going to be counterclockwise. We're going to go like 1, 2, 3, 4, 5, right? 5 seems to be a high number as opposed to 1, 2, 3. So 3 is going to be a better choice. So this carbon will be number 3. So, and then you'll have 3 iodo toluene, right? So you're going to call it maybe like 3 iodo toluene. So that's one option. Or you can also call it meta. So meta, so because this will kind of like imply that your iodo group, so iodo group is located in position 3 relative to the methyl group of toluene, right? So meta iodo toluene. So that's another way to name it. So then what else do we have? So that's going to be like the case for like a double substituted benzenes, right? So now here, so if we take a look at this guy, right? So that could also be named. So this apparently has the aniline piece, which is like one of the building blocks. So, but this aniline is substituted, right? Because it has a substituent. Theoretically, there was like an H, right? So if you look at this, it's going to be just aniline. But now we remove H and then switch it to the chlorine. So consequently, we'll have the substituted aniline. So let's number the carbons. So no matter how you go, this carbon will be number 4, right? Carbon number 1 is where the functional group of aniline is attached, right? So then in this case, we can call it what? So we have a couple options. So maybe let's take it to the Google Classroom. So, okay, let's take a look at the health of the compounds, right? So it looks like people say that they are basically like bad and they are carcinogens and toxic, right? So that's what's going to be our conclusion about those aromatic compounds, but at the same time, we are going to name them. So now let's take a look at compound C, for example, right? So we'll just like jump around a little bit and then let's try to name it. So name, please, right? So that's going to be the case here. So what do we name this compound? So here's a chance to remember what Cl means, right? As a functional group or the substituent. So in terms of the names, right? So here we have like 1 and 4, right? So what's going to be the name of this compound? So let's see what people think. So we are looking at compound C, right? So that's the example in question right now. So let's try to think about it and see what happens. Okay, so we have some responses coming in. So yeah, thank you for starting the effort. So then it looks like people just go with like one thing, which is p-chloroaniline, standing for para-chloroaniline, or you can also call it 4-chloroaniline, right? So basically, this one is para-chloroaniline, para-chloroaniline. So that's good. So now let's move on to the next one. So let's try something like more difficult. So yeah, here I'm going to highlight something such as that thing in the circle, right? So this one will be spelled as phenol, right? So again, so one letter difference, but a different structure, right? So phenol will be your like yellow, like black region, right? So, and then this is apparently a substituted phenol because you don't have like all the hydrogens in the ring in phenol. So those hydrogens are swapped, right, to a couple of chlorines. So now let's take a look at this guy, right? So good job with the with part C. Now let's take a look at D, right? So that's going to be our question or part D of this assignment, right? So question, so name. So what's going to be named? So like it's the same question, right? So, but what do we have here, right? So we have chloro groups here. There are two of them. And then we just need to like number this, right? So we cannot say like meta, so because we have three substituents here, right? Or like para will not be applicable or ortho, right? So like we need to use the numbers now. So and then we can go either clockwise or counterclockwise. So that's two options, but we need to make sure that we minimize the numbers, right? We can go either way, so it's all like free. So there's no like set direction, or it must be always clockwise, right? So we can go either way. So as long as we minimize the numbers for the carbons to which chlorines are attached, we'll be in a good shape. So let's take a look at this situation and see what happens, right? So we have a couple of chlorines. So things disappeared again. All right, so the base name will be phenol, right? So you should remember that, hopefully, or maybe not. So, but anyway, I put it on the board, right? So now let's see what happens here. So thank you for your effort. All right, so we have 2,4-dichlorobenzene unilaterally. Very good. So this one is 2. This carbon here is 4, right? So 2,4-dichlorobenzene, as opposed to potentially maybe like 1, 2, 3, 4, 5, 6, 4, 6. 4, 6 is a higher sequence, right, than 2, 4. So 2,4-dichlorobenzene. So well done. So 2,4 dichloro dichlorophenol, sorry, right? So dichlorophenol. So that's it. So like same thing here. Maybe I'll just like say it like verbally, right? So it's gonna be like sometimes a good idea. Somebody tells you benzoic acid, right? So or don't buy fruit punch Jarritos because it contains benzoic acid. Somebody tells you at the I don't know, caliente on campus, right? So go for tamarindo flavor. So that's going to be more helpful for you because it has no sodium benzoate, right? So as some people mentioned, it is a carcinogen. So and here we go. So this one will be, so let's circle that. So we can maybe make it yellow. So this is going to be the particular acid. So, and then we have the bromine. So now finally, let's just try to name that. So without my help. So see what we can make out of that, right? So it's going to be questions. So, and another kind of like very short question from me. So like, what's going to be the name of this compound, right? So who is that in the yellow circle? It's part B we're looking at. And it has two substituents, so it's not just kind of like the original acid, it's something else, right? Potentially still kind of like bad for health, carcinogen and such. So, but nevertheless, we need to be able to name it. All right, so let's see what happens. Oh, somebody already like turned in their responses. Good job. So some people like take action quite early in the mornings, so which is I guess good for you, productivity and stuff. So let's see what happens, right? So what's this kind of like thing in the yellow circle, so to speak, right? Okay, great. Thank you for the efforts here. So that looks like it's gonna be 3,5-dibromobenzoic acid. Okay, great job. So like well done. So we have 3,5-dibromobenzoic acid. So this is carbon number 3 right here. This one is 5, and then that's our like one and only way, right? To number it. So then carbon number 1 will be here, right? So that's where the carboxyl is attached. And yeah, that's going to be 3,5-dibromobenzoic acid. So is it 3,5? Yeah, it is 3,5. Yeah, perfect. Yeah, 3,5-dibromobenzoic acid. All right, so now let's see what else do we have. So as somebody mentioned, so the compounds are carcinogens, right? So, and in addition to that, so they are non-polar, right? So they're just like some facts that we can think about. So, and then they are also insoluble in water. So non-polar and insoluble. So this is going to be a good question for now. Maybe we'll put it on the exam as well, right? So then these things basically with the green arrows, so that's what we are not going to cover, right? So maybe you'll cover it in the future, right? So like at higher level organic chemistry courses, who knows? So yeah, but basically, so like something to be careful about, right? So like there could be like a trick question on the exam. For example, you have something like that, right? So here, green arrow number 1, do not undergo addition reactions like alkenes, right? So if you remember addition reactions of alkenes, that's great. So, but sometimes what could happen is that you might have something like this, right? So let's say you are going to have a random compound which contains several functional groups, right? So just like question in exam 1. So maybe you have something like that. So like this compound, okay? So if you look at this, you will see 2 like prominent non-alkane functional groups, right? Which is this one, that's going to be your aromatic piece, right? Or phenyl, by the way. So like speaking of names, so you see how close the spelling is, right? So phenol, that's when you had that group in the circle, but with OH, right? So phenyl is just that, right? It is just going to be benzene, which lost 1 hydrogen. So phenyl basically equals, in other words, C6H5, right? I'll draw it this way. And then also phenyl is going to be the same as that, right? So you can show it. Let's maybe show the expanded formulas. So like finally it's the time to show it, right? It's going to be carbons here. Then you'll have the alternating double and single bonds. So double, single, double, and then single again. So, and then you have 5 H's, right? So that's your C6H5 or phenyl. So this is going to be just a free valence, so free bond. So you have some sort of like electron here that potentially can be connected to something, right? So then this yellow electron decided to connect to like another carbon. So obviously in this particular example of the compound. So you have your phenyl, and then you have another functional group, which is going to be this one. So this one is just like an exam 1. That's going to be your alkene, right? Alkene functional group is in the purple circle. So, and then if you wanna, for example, do some sort of addition reaction, let's just add maybe bromine to that. So, so let's add Br2 to this compound, right? So now that's going to be the case. So that's going to be actually the first activity so that you can do. So let's see how we can figure this out, right? So this is the information so that tells you like what's possible, what's not possible or basically what's not possible for benzenes, right? So and benzene derivatives. So, but also you have the recollection, like what happens when alkenes react, right? So react with bromine, for example. So now let's take a look at this compound. And if you want to predict the product, you can give it a try, right? So you will have your kind of like molecule, which is pretty complicated. So it has this like benzene, but this benzene is substituted. And now you have the like alkene part. So then you have the reaction with plus Br2. And let's try to see what happens, right? So now that's the question. So you can go ahead and draw the product, which will be formed. So, but you need to like remember, right? So alkenes, that's gonna be like, you have alkene, you have Br2. So what's gonna be the product? So you need to like remember that, hopefully. At this point, right, it is just the addition reaction like of an alkene, right? Maybe now it's going to be like a time to review that. So that's a good push. And then we also say that the like benzenes or aromatic compounds do not undergo the addition reactions like alkenes. We have the alkene here part, which undergoes the addition reaction. We have the benzene part, which does not undergo the addition reaction, right? So here you just need to kind of like not overdo the products, right? So don't kind of like attach Br2 to any like a random double bond. So you need to be kind of like discerning, right, in this case. So you need to like figure out your like alkene, right? It is these groups. So this is where the reaction will happen. So this one, okay, well, just don't touch it, right? So, and that's it. That's what you will have. So basically you will need to only break one pi bond, right? So, but you need to like figure out which one. So yeah, you can give it a try, show the products, and this is gonna be for the extra points as usual. So let's do that. So maybe a different color here. So let's see what happens. Yeah, so like what will we get, right? Oh, sorry. So this is document camera, so which will go to the yeah, it will go to the right projector. All right, so that's what we're trying to figure out, right? So okay, good job. Yeah, so like since we say that the aromatic compounds, right, or the aromatic function group does not undergo addition reactions like alkenes, right? But alkenes undergo the addition reactions. So that's the logic here. So consequently, yeah, you just need to leave the phenyl group alone, right? So the aromatic compound kind of like preserves itself, right? And then here you have the bremination happening only at this alkene piece, right? And that's it. You are good. So added couple bromines, and yeah, that's all. That's all you have, right? So it's going to be also a good idea to be able to like draw that as a skeletal conformation. So just saying, so the skeletal way to draw that will be like this, right? So you will redraw your ring. So just leave it like intact, right? So then you are going to have no double bond anymore, right? And then you're going to have like a couple bromines, which we must show explicitly in the skeletal drawing, right? So we only can kind of like conceal carbons and hydrogens in the skeletal drawings. So yeah, that's the one. And we are now moving to the next part, right? Which will be alcohols. So let's take a look at the alcohols. So yeah, basically, maybe, so let's take a look at the like worksheet, right? So here we have it. So we have activity number 1. So which again, so you can give it a try here at the whiteboard or whatever presentation camera, document camera, right? So that's activity number 1. So we want to show the ionization of the OH bond, which as we know at this point is kind of like part of the alcohol functional group, right? So we want to show the ionization of this bond. So some of you did succeed in showing the ionization of the carboxylic acid, right? Which is much more complicated thing. So here you have just like one OH bond, which needs to ionize, right? So yeah, maybe let's try to give this activity a try. So yeah, before we actually get to the alcohol structures. So, but honestly, we did see the alcohol group just as a functional group at least, right? So now we're taking it a step further and then see what happens, right? So yeah, there we go. Yeah, colors. All right, awesome. So let's give that a try. Okay. So the slides are back. So we can count carbons, right? So that's entirely possible. So even though, yes, we're looking at the new compound type, but the point is that you need to use the previous knowledge, right? So you can show the carbon chains, right, in the skeletal conformation. So yeah, that's good. So here we have, we need to be careful with the number of carbons. We have 1, 2, 3, 4. We have 4 carbons. So this is good. So how many do we need to have? 5. So yeah, you need to, if you want to make it 5, you need to show the bond between this dot and the O. So
Would it need to go
or you
up?
can draw another carbon somewhere else.
I
Yeah.
feel like here.
Yeah, that's right. That's fine. So yeah, that's a good point that was just brought about now. So it's about the atoms that which we show explicitly, right? So you need to be careful of that. So they are just by themselves. They do not kind of like combine with the carbon, so to speak, right? At the same point. So here is your kind of like alcohol with an OH group. So yeah, that's great. So that's where dissociation will happen. Yeah, that's pretty much it, right? So like perfect, well done. So if you think about it, so again, so we have our previous knowledge, right? So like from the Gen Chem, such as the dissociation of water. So if you think about dissociation of water as a proxy of this reaction, so it's going to be something like that, right? So you'll have water. So it also contains the OH group, by the way, right? So with the 2 lone pairs. So once you do the ionization of water, the OH bond will break. And now you are going to have also, by the way, good job with the like reversibility arrows, right? So you are going to have your HO dot dot dot, and another lone pair is formed. So, and then you are going to have H plus. So here you have the acid behavior. H plus was shown, so that's good. And one thing, just kind of like don't leave the alcohol, the oxygen hanging. So you see this bond stayed, right? So you have HO and H plus. So the bond stays. So this is going to be the left bond. So that's the left bond. So now also show it here, maybe kind of like this way, right? So that's going to be still understandable that you have 1, 2, 3, 4, 5 carbons. And this carbon is connected directly to the oxygen, right? So that's it. Here at this point, there is only oxygen because it's shown explicitly, right? So it's not like you have somehow here carbon and oxygen, right? No, it's not the case. All right, so that is your alcohol dissociation. So now let's kind of like rewind a little bit and then take a look at the alcohols. So these are some examples of alcohols in nature, right? So bless you. So they exist kind of like in various very complicated structures, apparently. So we can start with something kind of like simple, such as maybe like ethanol, right? Which is just the 2 carbons in the chain. So, and that's like how the formula looks like, right? So for alcohols, you will notice that you kind of like have the same topic everywhere or common theme, right? You have this kind of like carbon and OH connection, right? So here, so if you look at here, this kind of like region, right? So with the red arrow, so technically in this band, there is a carbon, right? So, or more specifically like CH, right? So if you want to make it expanded, so you should be able to do that at this point in your life, right? So then here you have it, right? So COH, again, this is present. So if you look at some other examples, so here is the one. So the one in the purple circle, right? It's same thing, right? So here you have carbon OH bond. So if we want to like draw the alcohols, right? So like in the expanded fashion, so it's going to be like pretty straightforward, right? So maybe we're going to just show the like connection of the like H's to all the carbons, right? So we can do this for ethanol. Let's just kind of like show it for the sake of example, right? So CH3 will look like this. So then we'll have CH2. We just show explicitly two CH bonds. So finally, we'll show the O bond, right? And then maybe for your kind of like review purposes or for your learning purposes, right, show the OH bond in a different color. So maybe it will be helpful to like remember that, okay, well, once we have this like OH bond, right, in alcohol, or it's also present in carboxylic acid. So this bond is polar, right? This bond is polar. So this bond, CH or this CH or CC, even more so, are non-polar bonds, right? So like if you want to do the ionization, that's where the reaction will happen, right? So this bond will happen to break. So in the case of ionization, if you see the words like ionization, because you literally made ions, so this is an anion, this is a cation, right? Or the proton more specifically. So proton, this is going to be some kind of like random like anion, right? It's going to be enough for now. So like this is going to be like what will happen in ionization. So the OH bond will break. So everything else kind of like don't touch it, right? So because other bonds are considered non-polar, they will not dissociate as well as the polar bonds, right? So maybe, yeah, some people will still try to break carbon-carbon bond, right? So that's possible, but kind of like now I'm trying to kind of like be preemptive here. Just kind of like don't be like that, right? So don't break that bond all of a sudden if you are like requested to show the alcohol ionization, right? So that's going to be the OH bond that will break. Now let's see what else do we have here. So in terms of alcohols, so like you'll need to be able to name them. Oh, well, before we start naming, so let's also get to the perhaps the skeletal structures, right? So I'm going to show actually some sort of like alcohol structure, which will be maybe like this. So let's make it a little bit different. So and now we will make it more difficult. So let's do that. Okay, so here we go. So that's the structure, skeletal, right? Structure of an alcohol, right? So and then your task will be to convert it to the, let's do the condensed structure, right? Expanded, it's going to be too many bonds to write. So, but if you want to give it a try, so you can convert the skeletal structure to the condensed, right? So it is just kind of like CH2 written together, CH3 written together, not like bonds of CH for CH are shown, right? So you don't show the CH bonds basically, but you need to show the hydrogens. So if you want to give it a try, so here is an example, right? So again, so like same thing here. So basically consider that as an alkane, right? So if you close it like this, so you will just see the alkane with a bunch of carbons. And now one of the hydrogens was substituted, right? So now you have the OH group attached instead of the hydrogen. So we have one candidate, so maybe let's give a chance to some people who didn't go yet, so that's like you would use your chance, right? So it is just to show the condensed structure, right? So which is our previous knowledge. Okay, so yeah, well, go ahead. So we now will see, right, what we can make from this structure. Okay, so yeah, you can choose any color you want.
No, remind me, I'm only doing the CH.
Yeah, that's right. So it's going to be on like CH2, CH3, right? And then you don't have to show every single CH bond. Yeah, that's right. So that's going to be the condensed structure commencement, right? So we have CH3, CH2, another CH2, another CH2. And now we have here another band. It's going to be CH. Great. So notice that CH has to have 3 bonds, right? So yeah, that's it. So that's why it is CH, and then just show the OH, right? So like, yeah, or you can show a different color. Yeah, perfect. Okay, that's it. So that's your conversion from the skeletal structure to the condensed structure, right? So like very well done. So yeah, and we do that because we kind of like want to make sure that we don't miss the carbons, right? So since it will become kind of like important in the future. All right, so now that we kind of like showed all the carbons, so here we go. So we can get to the naming finally, right? So how do we name alcohols? So well, there is a convention basically that says that you need to find out the OH group, right? So once you have the OH group, you are going to like realize that, okay, well, you have the alcohol. So typically we'll be looking at some sort of like alkane chains like this one, right? Yeah, that's like where we are going to be in terms of our naming. So this is going to be like a cycle, right? So that's going to be like too much for us. All right, so this is going to be like a double alcohol, basically diol, right? So that will just say that you have two alcoholic groups. But for now, prior to exam 2, we'll be looking at the mono-substituted alcohols, right? So basically alcohol molecules with only one OH functional group attached directly to the carbon, right? So here also notice that you attach the OH to the sp3 hybridized carbon, which is going to be like a very like simple case as opposed to like some other situations, right? So here we go. So yeah, basically what we need to do is we are going to figure out where the alcohol is attached, right? And then the numbering of the carbon where the OH group is takes precedence over other substituents, right? So that's like what we are gonna have here. So that's number one. So then we are going to find out the longest chain that contains the OH group, basically. So here, if we take a look at this example, right? So maybe example like number 3. So here we have it, right? So we have the longest chain with the OH group. So let's take a look at the possibilities here. So we found the OH group, so it is here, right? Okay, very good. So now let's see what's going to be the longest carbon chain to which this group is attached, right? So let's trace some options here. So that's going to be like this. So maybe like this one, 2, 3, 4, right? So 4 carbons in the chain. So that's a possibility. How about another situation? What if we have 1, 2, 3, 4, 5, right? So 5 will be the longest chain with the OH group attached, right? So consequently, this is going to be our like parent chain that we'll be using in the name. So what we can see here is we'll have the word penta that signifies the longest chain, right? Maybe let's put it in blue, right? So that's going to be blue carbons like that. So this will be having the root penta. So the name of this alcohol will have the penta, pentane, right? So like it's almost like pentane, but it is substituted. Consequently, you are going to have not just pentane, but pentanol. So if you think about the name like alcohol, right? So it's going to be just like OL at the end. So then you are going to modify your name of pentane, right, into pentanol, so which will become the root of the name for this alcohol, right? So now you're going to number the chains, so and then you're going to minimize the number of the carbon to which the OH group is attached. So in this example, if we go like from like right to left, we're going to be like 1, 2, 3, 4. 4 carbon number 4 with OH, like too high of the number, right? If we number the group, the carbon chains from left to right, we'll be in a better shape because 1, 2, 3, 4, 5, right? So now carbon number 2 will bear the OH group, which is going to be like a lower number carbon, right? So then in alcohols, what happens is that you will have this kind of like designation, right? It's going to be like a special combination. You have 2 pentanol. So what does it mean? It means that your like alcoholic group alcohol is attached to carbon number 2. Hence, you have 2 pentanol part in the name, right? So that's kind of like what we need to like think about here. So 2 pentanol. So now substituents, right? So we have one substituent. Let's maybe make it green, for example. So it's going to be this guy, right? It is CH3. So CH3 is going to be the methyl. So carbon number 3 will have the methyl. Carbon number 2 will have our alcoholic group OH. And the longest chain, which contains the OH group, will be based on pentane, right? So hence the like name pentanol. All right, so now let's maybe take a look at this alcohol example, by the way, right? So we have our longest chain, which is going to be 1, 2, 3, 4, 5, 6, 7, right? So 7 carbons in the chain. So now we can number it maybe like this way, 1, 2, 3, or maybe like 1, 2, 3, right? So let's try to make our like educated kind of like approach here and try to name this alcohol, right? So now that's going to be the question to you all, right? So name this alcohol, right? So that's going to be like pretty straightforward here. So we have the longest chain with an OH group on that, right? And it's going to be the chain consisting of like 7 carbons here. It's like a straight chain of 7 carbons. So what's the root? So from the respective alkane, we should remember that, right? So then we're going to make some changes to the name, and then we're going to show the position of the OH group in this chain by the number, right? We're going to minimize the number of the carbon to which OH group is attached. We'll also make a switch from, let's say, pentane became pentanol, right? So this one is not pentane, obviously, right? Because it's not 5 carbons, right? It is 7 carbons. What's going to be the respective like parent alkane chain? So, but it will have this kind of like modified suffix, right? So let's take a look at what do we have. So we have some responses going in already. So that's good. So we have hept, right? So which will be our kind of like base name. That's great. So we'll have heptanol here. So that's a good call. So heptanol will be part of the name, right? So heptan, heptanol, right? So basically we will say, okay, well, we have 7 carbons, and then that's going to be our like alkane chain. So that contains the alcohol groups, so which will be signified by the suffix OL. So, but now we need to number it, right? So if we number from here, so because we need to show where exactly this OH group is attached, it can be maybe attached to like this carbon or that carbon or this one, right? So we need to show it exactly where it's at, right? So we can go like this, 1, 2, 3, 4, 5, right? On carbon 5, there is going to be the OH, right? And then you would call it 5-heptanol. But is it really good? Maybe not. How about this? 1, 2, 3. So it looks like 3 will be the lower number of the carbon to which the OH group is attached. And basically we have 3 options. So somebody said it is 5-heptanol, somebody said it is 3-heptanol. And 3-heptanol wins because we are going to have the smaller number of the carbon to which the OH group is attached. So consequently, the winner is 3-heptanol, right? So that's how it's built. On carbon number 3, there is an alcohol, and then this is attached to the kind of like heptane derivative, right? So if again you look at this, maybe this one is CH2, right, in your mind. So that's going to be just heptane. Now you removed one of the H's, became CH, and now you have OH here. Now you have your 3-heptanol, right? So now let's kind of like move on further a little bit. So what do we have in terms of activities? Let's see. So here we go. So yeah, maybe let's take a look at the name. So we are going to name for now only the alcohols with 1 OH group. So, but here we go. So let's try this one, right? So we have a couple substituents that we need to kind of like figure out. So it looks like it's those 2, right? The purple circles. These are going to be our substituents. So then we're going to show our longest chain of carbons, 1, 2, 3. So by the way, notice that this one is just oxygen with an H, right? That's your OH. So here, where I try to kind of show it, right, there is no carbon, right? It is just oxygen. So carbon is here at the kind of like bend, right? So we have carbons, 1, 2, 3, maybe 4, right? Or if we go this way, 1, 2, 3, 4, 5. So it looks like the longest chain of the carbons that contains the OH will be 5 carbons, right? So you can think about already kind of like the root that will be present here for this alcohol name. So here we go. So we have the root here, which is going to be pent, so maybe pentan, right? So since it is an alcohol, just add OL to that, right? So then you're going to do the numbering. So in terms of the numbering, so the OH group takes the precedence, right? So we are going to like attach the lowest number to the OH group in terms of to which carbon it is linked, right? So we can start naming from here. It's going to be 1, 2, 3, 4, 5, right? 5 pentanol, or from this end. So it is going to be a better choice because we're going to minimize the number, right? 1, 2, 3, 4, and 5. So you will have, looks like in this case, 1 pentanol, right? To carbon number 1. So the OL, OH thing is attached, which makes pentane and alcohol, right? So that's kind of a complicated way to say that, but it's one approach, right? So now you are going to deal with your substituents, right? So you are going to have here this one. Well, it's your job to remember what it is. So, but this one is called phenyl. It's relatively new. So, but we already saw it several times, to be honest, right? So that's going to be your like C6H5 piece in this huge purple circle. So you have phenyl and you have something that you're supposed to remember, right? So in a small purple circle. So now also remember that substituents are attached, are sequenced alphabetically. So now let's try to name it. So like, let's see if we can do that, right? So maybe like one more piece of effort here. So let's create the question here. Okay, so and name again. So here we go. You have apparently like 1 pentanol. So to carbon number 1, the OH group is attached, which makes pentane pentanol, right? So then you have 2 substituents in purple circles, right? Which again will be having the numbers of the carbons to which they are attached. And then also, like we know the names of those substituents, hopefully, right? At least this small circle, we should be able to confidently determine that. The biggest purple circle will be called the phenyl, right? It is C6H5 as opposed to benzene C6H6, right? So you just removed one H and you made this like, let's say, yellow bond, right? So yellow bond. So here, so that was made because benzene lost one of the hydrogens, right? And now it made the carbon-carbon bond instead. Okay, so let's see what we have here. So, okay, great. So we have some responses coming in. So we have basically methyl phenyl, MP, right? And it's going to be, so what do we have? We have 3 methyl, 1 phenyl, 1 pentanol. Okay, great. So it's going to be 3 methyl, right? So 3 methyl, 1 phenyl, 1 phenyl, and then it will continue to like 1 pentanol, 3 methyl, 1 phenyl, 1 pentanol. Okay, that is well done. So now let's kind of like take a look at the like next topic. It's going to be the kind of classification of alcohols. So here we go. So it's going to be like real quick. I'll just show it here. So hopefully you have a better quality once it's downloaded, right? So like, but here just kind of like, let's take a look at maybe some examples, right? So like of classes of alcohols, right? Such as primary, secondary, and tertiary alcohols, right? So primary alcohols, we have seen them already. So they are designated as such, right? So like one with a circle. And then if you want an example of the primary alcohol, that's going to be, for example, like this one, right? So let's draw the skeletal structure. And here you have OH, right? So yeah, basically what you need to do is count the surrounding carbons, right? So here you have it, right? So that's your carbon or CH2 group, which has the OH, right? So now the red carbon is attached only to 1 carbon, which is going to be blue. So that's going to be consequently primary alcohol, right? So that's just how it's structured. So by convention. So now let's take a look at another example. It's going to be secondary alcohols. So here we go. So let's say you have some like random alkyl chain, right? So you are going to have your alcohol like that, right? So you will directly kind of like show the carbon which has the OH as the red dot, right? So now let's count the surrounding carbons, so which will be blue, right? So the carbons which are directly attached to the red carbon, it's going to be two of them. Consequently, if you have the arrangement like that, you are going to obtain your secondary alcohol, right? So finally, tertiary alcohols. What are those, right? So we just need to be able to show examples of them, right? So that's all we need to do at this point in life. So let's show the OH, right? So as you can sense, we are going to find out that it's going to be attached to some sort of carbon, right? Otherwise, we'll not have an alcohol, right? So and now you have something like this. Let's imagine a couple ethyls, right? And here you have it like that, maybe, right? So maybe like more, like, but it doesn't matter, right? What we need to do is take a look at the kind of COH link. Okay, great. So we found it, right? So now we're going to count the carbons which are directly attached to the red carbon. So here, as we can see, the red carbon is directly attached to only 3 carbons, right? Not only, but the whole 3 carbons. And then that will make it like a tertiary alcohol. So one neighbor, primary, 2 neighbors, secondary, 3 neighbors, tertiary. So that's how it's kind of sequenced. So we don't have any like higher orders of alcohols, but that's where we are in terms of classification for now. So let's just kind of like stop it here. So you can stop by for questions, maybe find your exam real quick or go to the office and put down the name for the extra credit. All right, so let's see. So they're not by alphabet, unfortunately. So, but we can. Okay, so let's see. We just go to the office. Yeah, I'll give you industrious here. So let's see. So extra credits, sign up. So if you want to pick up the alcohol, go to the office. I'll be there in like 5 minutes. Yeah, that's right. So yeah, this will be sent out like 1 day, 1 or 2 days before the event. So, yeah, tomorrow, I think.
I was just wondering how much, extra, like how many points are added for like if you did a question in class.
So it's going to be like at least 3 points.
At least 3
Yeah,
points. Okay.
Okay, so yeah, you want to sign up or you already there, right? So you are Brian. Okay, so.
Should I get my exam or should I wait?
So I need to find it. So they are not in the order. So yeah, you just go to the office and then yeah, you will pick it up. And then like, if you want to pick up the exam, go to the office. I'll be there in like 5 minutes.
And remind me where your office is.
117G. Yeah. Okay, great. So we have another one. Okay, so yeah.
The extra credit.
Yeah, you can sign up there. No, just if you look at any health team and do that, and you don't remove it, the bottom broken, but you want to traditionally add. Now all the added.
All right.
Yeah, so this is going to be the addition. Substitution is that like when you cut, for example, let's say, so here is like the substitution, right? So let's say.
But I just left it there.
Oh, okay, yeah, that's fine. Yeah, I'll deal with that. So the substitution, so it's like this, right? Let's say you have methane originally, right? So and then you add to that. So that's just the term that we have to use. So you are making this, right? So the final compound will look like this.
Yes.
It has the 3 H's, not 4, right? One carbon, and now it has the chlorine instead of H. So
that
now
would be substitution.
that's a substitution, yeah, exactly. So now addition will be like A plus B equals AB, right? So and it's going to be like this. So let's say we have, for example, like simple stuff, right? So CH2 plus bromine, for example, too, right? And now it makes this bond is broken. You're right. So you do break the bond, but then you just kind of add. CH2, Br2, CH2, CH2, Br2. Oh.
So the difference is that in the rings, none of the like pi bonds. get
Yeah, that's right. So yeah, just leave them alone. Yeah, exactly. So no pi bonds in the rings are broken.
broken.
So
That
yeah,
makes a little more sense.
like in this case, yeah, that's what we're gonna go with. So yeah, just leave the rings alone, right? And redraw them. So, but if you see the like alkene attached to the ring somehow, right, as we again saw the example, then you will be focusing on the alkene and how this will undergo the addition reaction. So just that is an alkene, right? It could theoretically have some sort of like phenyl here, right? So then this will just become this with the pH, right? So CH, Br, and that's it. So C6H5, CH2, CH2, Br2. C6H5. So this one became this would be CH, by the way, right? CH, CH2, Br2. So you just like added them all, right?
Yes. So
Yeah.
I have a couple of other questions. So these ones are kind of smaller. So when we do the benzoic acid compounds, I don't think we have them written out. Do you write benzoic acid as 2 words?
Yeah, it's the 2 words. Yeah. You can the substituents can be attached to the word benzoic, but then between benzoic and acid you will have the space. Benzoic space acid. Yeah.
Also, I saw on the slides, I'm not sure if it was a typo, it kind of looked like hydroxy and hydroxyl were kind of interchangeable. Is that?
Yeah, that's fine. So yeah, they can be interchangeable. So if you like look at the like OH by itself, right? So yeah, so you can call it like a hydroxy group or hydroxyl. So yeah, that's fine. Yeah.
Thank you for
Yeah.
this.
Hydroxide, that's when you make the like OH minus association.
Oh, are there CSMs?
No. But,
Oh.
yeah, you can just take them from the office because I need to sort them. Yeah.
Okay, I see. I'm sorry.
All right, so yeah, you can just like go to the office if you want to give the exam. I'll give you. So yeah.
Oh, quick question with the exam, do you know when the extra credit is due, like,
So sometime soon. So yeah, if anything, you will see the increase in the scores. So
okay.
yeah,
Perfect.
it's not gonna like decrease, right? So, but it will be there.
Well, we
So.
don't have to do anything with it, right?
No. Yeah, I'll just like do those calculations. So it's just like on me, and then yeah, you will see the change, and then the extra credit will disappear. Those kind of like 0 and 1 challenge assignment. So and then you will see the updated score higher, right? So as long as you gain something on those challenge assignments, it will like increase by the number of points which you gain, right? It's going to be, let's say, 4 plus 4, then you will get like +8 to your exam, and then let's say it goes up from like 70 to 78, right? So if you score 70,
Okay, thank you, appreciate it. Have a good day.
you're welcome. So yeah, if you want to pick up the exam, it's gonna be in the
I was
office.
gonna actually ask
I'll
about
be
the
there. Huh?
I was gonna ask you about the meeting tonight.
The meeting.
Do you know whether you're gonna do it tonight or tomorrow?
The review.
Yeah, the review.
Yeah, the review most likely will be tomorrow morning. So yeah,
Okay.
because there is like gonna be like a bunch of stuff that needs to be done. So yeah, and then I'll just do it like early on Wednesday. Like
Yeah, all right, because I have class, that's all I'm gonna be able to make. Are you gonna?
it will be recorded anyway. So it will be recorded and published. So yeah, you can just
When
watch
you
it.
normally post this right on,
Huh?
you post it right on the Brightspace?
I'll post the link on Brightspace.
Okay.
Yeah, that's right. And then you can
All right,
watch it
perfect. Thank you so
online.
much.
Yeah.
Have a
Okay.
good one.
No problem. All right. So, and now we are out. Bye, everyone.